like I said at the beginning, today is not super content heavy. Today is definitely more about trying to come up with some semblance of a plan for the exam. I believe the exam is on May 12th, if I recall correctly. So with that in mind, you've got what, roughly a month and a half, give or take, maybe a little bit more than a month and a half. And at this point in time, your teachers hopefully are kind of winding down curriculum and starting to prepare for the exam. You should both be wrapping up, or at least in the process of wrapping up your unit on torque. I would imagine. Is that true for both of you? That you guys are at least in that ballpark?
I'm on torque, and like angular
Yeah,
kinematics and inertia.
cool. Sylvia, is that the same for you?
Yeah, probably.
Just kind of in that general ballpark. Cool. Um, so hopefully, after that, you're pretty close to finish with the material, and you should be, moving into that kind of prepping area. Um, So what we're going to do, we're going to talk about some key terms, the grading rubric. We're not going to go too far into any of this stuff, of course. The types of free response questions, and we do have a few practice problems that we can look at just to kind of give you a feel if you haven't seen much of the exam yet. Just to give you a feel of like what you can expect, the types of questions, not just like content, but like how they're structured and what that means for you in terms of like what to pay attention to. Is this for both of you? Is this your first AP exam, or have you both taken ones prior to this?
I've taken prior ones.
Prior,
Same.
Jackson? Same. Okay, cool. So then you guys are at least familiar with the general structure of an AP exam. Have you taken any science APs prior to this? Chemistry or bio?
No.
Not me either.
Okay. So, then this will be a slight departure from what you've seen before because, the science AP exams are somewhat unique relative to the others. But so one of the things I think is really helpful to think about is if you had to take the exam today, how do you think you would do? Now, there's obviously a lot packed into that question because, again, you might not have done a ton of prep for like the content, not only the content, but also the structure and the format and the timing. But I think it's a good idea to reflect on if you were forced to sit down and spend 3 hours today, do you think you'd be prepared? The reason why I think that's helpful is it really forces you to clarify or like crystallize what aspects of the exam you're not feeling prepared for. So if you sit down and you think about it, and you're like, okay, what if a kinematics question came up? Because kinematics is at the beginning of the semester, right? Beginning of the class. So if you think about it in those terms, you're like, oh my God, I'm not ready for kinematics. Then okay, kinematics is something I need to pay attention to. Or, in the opposite direction, if you're thinking about torque and angular momentum and rotational kinematics and all that kind of stuff, if you're not feeling prepared for that, obviously, again, you're wrapping those up. But it just kind of helps you clarify what you'll want to pay attention to on top of really force you to start digging, or not digging, but like creating a plan week by week. And I think that's what's important is starting today or this week, right? You do have a month and a half, maybe, give or take a little bit more than that, but it's going to come up fast. I'm sure you guys have a bunch of other finals that you're preparing for, and these AP exams are not anything to be taken lightly. So other questions you want to consider is, is this the first AP exam? We've already talked about that, so that's kind of behind us now. But are you also preparing for other AP exams, right? If you've got 2 or 3 that you're taking, how are you going to chop up the time accordingly so that you can devote enough time to every single one of your classes or every single one of your AP exams? And then kind of along the lines of what I said earlier is, by thinking about these questions, it'll help you consider what you need to, really focus on. Do either of you have specific subject areas that you feel very either ill prepared for, or you feel like are by far harder than other sections of this exam, or excuse me, of the class?
Projectile motion and like gravity and centripetal force and acceleration.
Okay. So yeah,
Mine's probably just centripetal force, but I think that's more just because it's newer for me right now.
fair enough. Yeah. Jackson, would you say the same, that centripetal force and circular motion is challenging because it's new?
I did it at the end of last semester,
Oh, okay.
but I feel like I didn't go that much into it.
Okay. Okay. Cool. That's good to know. We'll talk a few or talk for a few minutes probably at the end about some of those subjects. There might be a couple things we can let you, leave you guys with to go home with. Yeah, I'm assuming you're already home, but you get the idea. I do want to talk briefly about this document here. Now, this document is on their website, so you can easily look this up if you want to. I recommend very, very highly scouring through this document. The reason why is a lot of these terms are very, very specific to the ACT, or ACT. I work with ACT all the time, so I apologize. I might be doing that a couple times today. But a lot of these, have very specific meanings for the AP exams, and it's really, really important that you understand what the difference between, evaluate and calculate may be, right? Or derive and evaluate, or derive and calculate, right? And describing versus, explaining, right? Those have kind of particular meanings, and you need to be able to, recognize those in the moment. Another good example would be sketch, draw versus plot, right? Sketch means, you can see here, labels may or may not be required. So they might be just looking for the general structure of the relationship between two quantities, right? Whereas plot, you're going to need some scale, right? And units, right? So that's a more involved process than sketching or drawing. And I've seen this multiple times in working with students as they're preparing for their AP exam, where they kind of confuse or conflate the two, and they'll sketch something when they are asked to plot something, right? So these terms, although they kind of seem obvious from an outsider's perspective, they really do mean very specific things, and it's important to make sure you're comfortable with those. So I'm not going to talk any more about that for the moment, but just keep that in mind. That's probably a good document to look over between now and the exam, maybe even a couple times, just so you, again, have those really, really clarified in your own mind. This is another aspect of the exam that I think is worthwhile to go over. Now, this says 2018. The reason it's 2018 is just because, from what I recall, that's the most recent information that they have. All of this is applicable to this year's exam. But I think going through these points is helpful as well. You can see here, oops, sorry. Number 5, where it says scoring guidelines typically show numerical results using 9.8 meters per second squared. 10 meters per second squared is also acceptable. So unless they specifically say, like, don't use 10, you're probably fine there, especially if it's one of those questions where you're moving quickly and you don't need to do a ton of in-depth calculation. But other topics here, they don't double penalize you, right? So if you make a mistake early on in the problem, and that mistake causes an answer later on to be incorrect as well, they won't penalize you a second time. They'll just penalize you for the first time, assuming your work after that is reasonable, right? And then there's a couple other things here that would be worthwhile to go over. Significant digits, they're not typically applied. You can see here on number 6 at the bottom. So it's not that you want to ignore those entirely, but don't get hung up too much on those, because they're looking for general answers. Are you, at least, do you have the correct answer, but maybe you had one extra, sig fig. So things like that are, again, aspects of the exam that you want to have dialed in before you get closer to the exam, right? You should be kind of thinking about these, so that way you're practicing these skills and aware of these things over the next month and a half. Okay. The types of questions on the exam. This is, again, another aspect of the exam that I want you to be familiar with as soon as possible. I definitely don't want you guys worrying about this, the structure, the basic format of the exam, late April, early May, right? So it's broken up into two different sections, each of them an hour and a half long. There's the 50 multiple choice questions, and then they have this, the multi-select questions where they'll, it's the select all that apply, or whatever it may be. So you're going to have potentially multiple responses to a single question, right? And then there's the 5 free response questions, which include experimental design, these qualitative, quantitative translations, the short answer, and then the short answer paragraph questions. And I think, again, it's helpful to be familiar with what that means. So that way on exam day, you're not kind of like surprised by, oh, I didn't know I was going to have to do an experimental design problem. I think experimental design specifically is one of the types of problems that you should, no matter how comfortable you feel with the content, you should always drill this experimental design. Just because they always come up with some unique and novel way to test your ability to design an experiment that's sensible and also assess another experiment that's kind of like given to you. Like, does this experiment make sense? Why or why not? What are the pitfalls of it? You know, that kind of thing. So even if you're really, really confident with the material, those experimental design questions can be tricky because they're somewhat unique to these AP exams. Okay. Content breakdown. Now, this is pretty important. I guess, yeah, I completely, forgot to, well, actually, never mind. I'll just move on. This here can be a good guideline too to dictating where you're going to spend your time. So theoretically or hypothetically, right, let's say you feel equally comfortable on all of the 7 units. You definitely don't want to spend, and you're going to devote 100 hours over the next month and a half. That's probably on the hand, but whatever. You're going to devote 50 hours over the next month and a half to studying for this exam. You should probably divvy that up proportionally to the percentages that we see here. So if you are spending 50 hours in total, you definitely don't want to spend 20 hours on simple harmonic motion, right? So these are guidelines to help control where you're spending your time. Of course, factor in, like we talked about earlier, what you're comfortable with and what you're not. If you're absolutely 100% comfortable with kinematics, then maybe you don't need to spend that much time, even though it's a good chunk of the test, right? And then I think, sorry, I can't remember which one of you said circular motion and gravitation. I believe, Jackson, you said circular motion and gravitation you didn't feel great about.
Mm-hmm.
You can see here, it's not a big component of the exam. So not, don't obviously, misunderstand. Obviously, you want to study this and make sure you're feeling comfortable, but you can take a little bit of solace in the fact that it's a relatively small chunk of the exam, right? Energy, you can see that's a big one. Dynamics, that's not surprising. That's a big one, right? Momentum, a big one. So, keep that in mind as you're putting together a plan over the next, month and a half. I'll just kind of reiterate, I'm sure you're both aware of this. The pre-pandemic, there were other units included in this exam, and that's reflected in the formula sheet, which we're going to talk about in just a minute. You can see here the test only will go up through unit 7. So I'm assuming your teachers have already made that adjustment, and that's not a shock to you. But okay, this here, humor me for a moment, because this is a really, really important topic here. A lot of students think physics is just math. Like, that's what you hear. You've probably heard that. Actually, have either of you heard that before?
Yeah, I have.
Okay. And I understand where people are coming from when they say physics is just math, because if you look at physics from the outside, from the outsider's perspective, if you're not familiar with it, what you tend to see is just math, right? It's just a bunch of formulas all over the place, right? And so it's very tempting to think of physics as just math. While math is very important, it's not math, right? You have to kind of approach this from the perspective of concepts first, and then the math are just the tools that you're going to use to solve a problem or convey a point, right? Or basically, create an opportunity for you to come up with a solution, right? That's what math is to physics. Now, you could quibble with the characterization I have a little bit if you want to kind of think about like high-end physics, or whatever. But for high school physics, which is what you guys are at, physics is science that utilizes math very, very heavily, right? And the reason why, again, that's important is it helps ground you in like, okay, I can use the formulas all day long, because Do either of you guys have a huge issue with the formulas? Or are they, for the most part, fairly straightforward?
Or it's straightforward.
Sylvia, would you kind of say something similar? Not that they're not that
Yeah,
it's
I'd say
easy per se,
straightforward probably.
but it's mostly just algebra, right? And so the formulas are relatively straightforward. I relatively, we can argue about that, but if you approach it from I know the formula, so I'll be fine, you miss all of the important actual physics that are going on, right? And you need to kind of refocus on what's important, right? The concepts drive your problem solving, and then you pick up mathematical tools as you go through it, right? If you can make that switch, if you can really focus on conceptually what's going on, you'll be far better off on an exam like the AP exam, where they're not going to make things easy. These are not, oh, there's a force applied and here's a mass, what's the acceleration, right? We know that's not going to be the case, right? These are very conceptually deep problems that they're going to throw your way. And they're going to ask you in very odd ways, right? They're going to ask you questions that you might not have seen before. They do a good job at, kind of keeping things really, really fresh. So ground yourself in the concepts and understand that the formulas are going to come along for the ride, basically. Are there any questions about that? Again, this is a really important point, so I kind of want to stick on this. Do you guys have any thoughts on that or concerns, or do you kind of get what I'm saying there? Good, I'm assuming. Cool. Okay. So with that being said, I just want to briefly talk about the formula sheet. I'm assuming you've both seen this at this point in time. As far as I can tell, I checked this about a week ago. This is still the formula sheet that is given to you. I could be wrong. They might change this, but what I want to draw your attention to is the top right corner that's circled in red. Hopefully that should look foreign to you, because that's not going to be on the exam. This is, you can see at the top where it says effective 2015. This is a remnant of the older version of the exam when they included a couple other units. So that top right section, assuming that that's the formula sheet you'll actually get this year, and assuming that's the formula sheet that you've been using throughout the course, obviously it doesn't mean anything to us for this exam. The rest of the stuff, of course, the geometry and the trig, of course, those are things that you should be familiar with and maybe freshen up on certain things if need be. And then the left column, of course, is where the meat of this course comes from. All of these formulas, you should be, I would say, every week, maybe even twice a week, looking through them and making sure you understand exactly what every single term means. The reason why is, yes, I know you'll have this, on the exam, and yeah, you can look these up really quickly, but you don't want this to be a stumbling block at all. You want to be able to, look at the formulas and be like, okay, I know exactly what that means, and this is the occasion in which I'm going to use it, right? You don't want this to be a stumbling block. You want the math and the formulas to just be kind of background that you're going to, again, kind of pick up along the way. Not sure. Yeah, I think that's probably all I want to say there. Okay, so that's honestly most of what I wanted to talk about in terms of like format and structure. We didn't talk about like a lot of the specifics. I have a couple practice problems that we can look at that kind of we can go into a little more depth or a little more detail as far as like what you can expect to see, right? Content, the way the words or the way the questions are phrased. But before we do that, because I do want to kind of look at a couple of these, we're doing pretty good so far. Yeah, we're about 20 minutes in. Do you guys have any particular things that you'd like to discuss? Content, logistics, concerns, anything at all? This is kind of free reign now.
I don't have anything specific personally.
I just have like a question. Are the multiple choice questions, are they more conceptual rather than calculations?
Yes, good question. And actually, I'm glad you brought that up because I meant to talk about it, so thank you. Yes, for the most part, the multiple choice are going to be far more conceptual. Now, I say that with a little bit of a grimace on my face because that kind of implies like, oh, the free response are very calculational heavy. And That's true in one sense, but again, keep in mind the free response are still conceptually very, very heavy. But at the end of the day, yes, Jackson, the free response, or excuse me, the multiple choice are going to be far more conceptual or concept heavy and like quick calculations, right? So if you were to ever see a problem that gave you a force and a mass and asked you to calculate an acceleration, it would be a multiple choice question, not like one full free response question. So yeah, so the multiple choice are definitely driving home concepts more so, or I should say are emphasizing the calculations less so. Other questions before we kind of jump in? Like I said, we might not spend the full hour today. I kind of wanted to just talk about a few things, and then actually I want to kind of walk through, since it's just the two of us, we might as well walk through some plan for both of you. Okay, so we're gonna look at a couple questions real quick, and I just want to highlight a few things. So, oops. So a problem like, well, I should say every problem you'll see, they'll tell you the number of points and the suggested time, right? Now, obviously those are just guidelines, but they give you a sense of, obviously how much time you should be spending, but like the level of depth that you need to be going into. For example, if we look at this problem compared to the next one, I think this one's 25 minutes, right? So this one you can imagine you're going to be doing a lot more with. Whereas this problem here, you're going to derive, I would say the biggest time sink for this problem might be something like this, where you're deriving the equation, right? And then the other things are going to be, once you have this equation, what can you do with that? And so practicing over the next month and a half, recognizing, I mean, not that you have to recognize what the numbers are, but recognizing when you see a number, what that kind of entails as far as what's going to be asked of you, is somewhat of a skill in and of itself, because again, you don't want to be spending 25 minutes here and feel like, okay, that was a good use of my time, and then on like the next question spending 10 minutes, right? They give you these guidelines because they expect a certain amount of effort, a certain amount of work to be done on those types of questions. Okay, so question like this, right? They give us a spacecraft, there's the Earth, they tell us it's the radius away, and they're going to ask you to draw and label the forces. So this is going back to the very beginning of the class, right? I mean, maybe a month in, where you had to start doing free body diagrams. So that's something that, you might not have done much of that in a while, especially when you got into the, the energy units and the momentum units. You didn't do a ton of free body diagrams, right? That would be a skill that you probably want to brush up on, right? And then, part B, they ask you to derive this equation, derive an equation for the orbital period. And this here is really, really important. They want you to use physical quantities, and so your derivation is going to be algebraic. You're not going to have any numbers here. Well, I should say, your answer is not going to be numerically based. It's going to be algebraically or symbolically based, right? So if you have any concerns about what that means and what that looks like, that's something you probably want to start addressing. Do you guys understand? I guess I'll just ask you, do you both understand what I mean when I say symbolically or algebraically derived?
Yes, sir.
Yeah, like just using variables.
Just using variables and any physical constants. So like G might show up, right? Capital G might show up, right? Those types of things. Absolutely. And if you're not comfortable with that, then again, you want to start addressing that now, because that's likely, if not almost guaranteed, to show up on the exam. A lot of students really hate doing that stuff. And so it's one of those things that I always feel compelled to highlight. Okay, let's look at the next. This is just the same problem. I don't think there's a whole lot that I want to talk about there. Yeah, this one here. So a question like this, right? They give you some setup, and then they're going to talk about, student hypothesizes something, right? And then they're going to say, for this one, state a basic physics principle or law the student could use in designing an experiment to test the hypothesis. So what do you guys think they're referring to there? What does that kind of imply? What do you think they're looking for there? I know, we haven't really dealt with this problem, but like, give me an example of like a physical principle or physics principle or law that could be, applicable here. Any guesses? So what they're referring to here is they want to see you reference or utilize something like conservation of energy, conservation of momentum, right? Newton's second law, right? Those types of things. They're not necessarily looking for you to solve this problem or, design an experiment here. They're saying for part one, we want you to recognize what principle could be used to aid you in solving this problem or designing this experiment, right? So that would be another thing that I would pay attention to or kind of, review over the next month and a half is what big principles exist out there, right? Again, I've already kind of, mentioned a few, right? Newton's second law, conservation of momentum, conservation of energy. Like those are, I would say, like the three really, really crucial ones, right? And be be ready to, pull those out at the relevant time, right? Those again are kind of somewhat nebulous or somewhat not ambiguous, but kind of like they seem to kind of come out of nowhere, but you really need to be able to recognize, oh, this is conservation momentum, and I'm going to label it as such. And then number two, right, they say use this principle, right, and determine an expression, which again, basically is like synonymous for derive here, right, for the spring constant in terms of quantities that can be obtained, right? So this in terms, right, are you guys both familiar and comfortable with what that means? You can just give a thumbs up if yes, or yeah. I'm assuming that means yes. Okay.
Yeah, I can only raise my hand.
What? Oh, okay. So Jackson, does that make sense when they say in terms of something? Are you comfortable with what that means?
Yeah.
Silvio?
Yes, sir.
Perfect. Awesome. Thank you, guys. All right. I think we've got a couple more things to look at real quick, and then we'll probably, unless you guys have other questions. Okay, actually, this here is important. So quantity to be measured, right? That probably that probably makes sense, but you're going to be talking about like things like distance, time, right? Mass. You're not going to be measuring, typically you won't be measuring like force, right? Force is often something that you derive based on, maybe like acceleration, which is, something you derive based on distance, or excuse me, change in velocity over time, right? So keep that in mind. These quantities to be measured are not quantities that you calculate, right? These are quantities that you would physically with a tape, ruler, or tape machine, or a ruler, or stopwatch, like those types of things, right? Those are what they're looking for when they say quantity to be measured, right? Be careful with saying things like force or acceleration, right? All of those things are derived from other measurements, right? And then you'll have your symbol for your quantity, right? Which of course is just, whatever the relevant symbol is. And then the measurement tool that you would use, right? Does that make sense? Do you guys, this is, I think, an important point too. Do you guys understand what I mean by like quantity to be measured is typically not force or like acceleration, right? Do you guys both get that?
Mm-hmm.
Yeah.
Cool. Perfect. All right. And then let's see. I don't think there's a lot that I wanted to say there. This is, I think, just another practice problem that we could go through if you guys wanted to. Yeah, I don't think there's actually anything that I specifically wanted to talk about for that problem. These are just options that we do have. Okay, well, that's pretty much what I wanted to get through today. I wanted to leave about 25, 30 minutes or so And so we actually did a pretty good job. 25 or 30 minutes to kind of discuss some questions that you might have. So do you guys have any questions? Again, this could be like specific topics, concepts, or again, some logistics, or maybe ideas for like, or sort of questions about ideas in terms of what you should be doing moving forward.
I do have one question.
Sure. Yeah.
Do you have any ways or like websites or anything that you could use for more like kids who are better like kinetic learning? Because I'm not really good at just like looking at notes or doing that type of stuff.
Sure. So there's a couple of sites that I often recommend. And are you referring to kinesthetic learning?
Yeah.
Um, I'll be honest with you, I'm fairly familiar with the term, not super familiar with the term. But I know it kind of more or less has to do with, being able to manipulate something and actually see something kind of in action, right? Is that
Correct.
kind of what
Yeah.
you're referring to? So one of the sites that I do refer kids to or students to a lot is called physicsclassroom.org or sorry, .com. Physics class, and I can put this in the chat room if it's helpful. Physicsclassroom.com. I'm pretty sure that's just the website. You can also just Google Physics Classroom, of course. They have a lot of little applets that can be helpful. They have a lot of like visuals associated with the different concepts. I'm not quite sure if it's exactly what you would be looking for, but I think it's a good place to start. Is there a specific topic that you're looking for, or is it just in general?
Just in general.
Okay. What I would do then, if that's the case, is Google, because if I just type in applets for forces physics, I'm Googling right now applets for forces, and then I just put physics on the end of it. And then the first one that comes up, let's see, I have heard of this site before, so I'm wondering if this is the first site that I'm coming up with is what's called compadre.org. And I've heard of this, so I think that's probably a good sign. I'll be honest, I'd have to look at this more thoroughly. They reference the physics classroom, oddly enough. Desmos, if you need a little bit of work with like graphically or visualizing graphs, that is always a good idea. This site is referencing Physics Classroom a lot. So this site actually might just be a site that kind of gathers up resources for students, which is actually probably good because that gives you a wider range of options. And then they also reference what's called PHET or FET, which is another site I've heard of. So I think what I'm going to do is throw this site in the chat room as well, because that looks to be a pretty good resource also. And I think the pre-college stat. And then on the left side, on the tabs on the left side, you see like conceptual physics, algebra based, and if you scroll to the algebra based, you'll see all different types of units. So that covers pretty much everything. I don't see, I guess it would probably be, torque would probably be, yeah, actually I don't see torque there, but I would say those two would be a good place to start. Does that kind of help?
Thank you.
Cool. That's actually a really good question. I should do more research into that because, again, I always send students to Physics Classroom because they do have some interactive applets, but I'm sure there's others that are other websites out there. Oh, obviously there are other websites out there that could be helpful as well. So, cool. Other questions, concerns at all?
There's one question type on the for your response called like quantitative or qualitative.
Mm-hmm.
So I don't. I mean, I know what like quantitative and qualitative observations are, but like I don't know what that would look like in a question.
Sure. So what that's usually looks like is it's a question that's going to be like often a mixture of both, right? So if I look at, for example, let's see, um, this question here. This question here is an experimental design question, right? If you look at it, there's not a whole lot in terms of like actually doing calculations here, right? This is very much conceptual, right, and experimental design. A quantitative and the qualitative is they're going to actually kind of ask you to do a lot of everything, if that makes sense. So you're going to do, like, for example, I think the first one, maybe that's actually not a good, I think third one would fall into this category. I made them, man, I guess I didn't do a great job of including, because these are all just, anyways, those are going to be the questions where you're going to actually do a decent amount of calculation, as well as like some qualitative assessment of what's going on or analysis. Does that kind of make sense?
Mhm.
I know I'm kind of restating what it sounds like it is, but if you look at like the counter examples like these, they're not asking you to do much calculation, right? Except for maybe you could argue like the derivation, but I would actually say that's not really a calculation, right? Calculation usually implies like you're going to get a numerical answer, right? So these would be counter examples to those types of questions. Those questions are going to, be similar in a lot of ways to these, but then they're going to ask you to actually give numerical answers. So does that kind of answer or address your question?
Yeah.
Okay. Let's see. Other questions before we kind of wrap up? I just want to take a few more minutes of your guys' time just to make sure you're feeling, confident confident with some semblance of a plan. So any questions before we kind of wrap up? Good. Okay, so do me a favor, both of you, just turn your mics on for the next few minutes, assuming that it's not like overly, loud or perfect. Thank you guys. Okay, so both of you, and Sylvia, we'll start with you. When do you plan to start studying for this exam? And do you know that your teacher is going to be doing a lot to help you?
I personally don't know if my teacher's gonna do a lot to help me,
Okay,
but I have already started studying for this one.
cool. And what does your study plan look like so far?
So far, I've just been using like some websites and then some apps on my phone just to start
Okay.
reviewing some of the earlier stuff that we've learned.
Okay. Have you looked? I would say one of the things you said a couple of websites. So, have you actually used the College Board yet?
I have used College Board, yeah.
Have you looked at previous free response questions?
I don't think I have.
Okay. Jackson, same question to you, obviously, or same comment to you. I'm going to find the website and I'm going to put it in the classroom, or in the chat room. Sorry, it's late. My brain apparently is beyond its capacity. Okay. So I'm going to put this link in the chat room here. If you go to this site, you'll see, you scroll down a little ways, they have previous exams from 2021, 2020, I think is on there too. Actually, no, yeah, 2020 is on there, 2019, 2018, 17, 16, and 15. So you have, what is that? 4, 5, 6, 7 years worth of exams, free response questions from the exam. And not only do they have the questions, they have every question, but they also have example responses that students gave for these questions. And they'll give you examples of students who got full credit, who got partial credit, and students who got very little credit. So you'll see the difference between a quality answer and an answer that's not so, right? And they'll give you not only that, but they'll give you guidelines for where they took off points or what they were expecting to see for those answers. I think that is about as invaluable as anything you're going to see, or about as valuable as anything you're going to see, right? Because not only are you seeing content, but you're seeing exactly how they were graded in the past. And at this point, you have 7 years worth of exams that you can pour through. So definitely look at those exams questions really, really heavily over the next month and a half. And maybe focus on one exam a year, or one year a week, excuse me. So like maybe this week, start with the 2015 free response questions, next week 16, and so on, and kind of get closer and closer and closer to the current day as you lead up to the exam. Does that kind of make sense?
Mhm.
Cool.
Yep.
Okay, so Jackson, same basic question to you. How is your studying coming along so far?
I have not started studying yet.
Okay.
Actually, we haven't. We're still on like rotation,
Mhm.
and then we still have to get to, I think, like harmonic motion.
Okay. Yeah. Do you think, or do you know your teacher is going to do a lot to help with the study over the next month?
I think we'll have at least a couple of weeks
Okay.
before the exam to study.
Good. Silvio, this is applicable to you. I would imagine your teachers will kind of reference some of these exams, right? They're probably going to pull material from this website, but they might not, give you everything, right? You might not have enough time to work through all of this stuff in class. So, start looking at it now and really familiarize yourself with the different types of questions. Again, what served as a full credit or full credit response, what gave partial credit, right? And really pay attention to the choice of the words and the reasoning behind everything, right? Because that's as important as anything, is not only that you got the right answer, but you explained why you got that answer and why that answer is, correct, and what kind of rationalization there was for it, right?
Yeah.
Okay, so obviously that's not like a very detailed plan, but I think the point is you want to get started today, tonight, this week, kind of thing, right? Don't wait until the end of April to start studying for an exam that is going to take 3 hours, right? If either of you are involved with test prep with us, you realize that we spend months getting prepared for an ACT exam. This is no different, right? This is a long exam, a long form exam that you want to be really, really well prepared for. So start ASAP. You both should have my email at this point in time. So if you have questions along the way, you're more than welcome to reach out and say like, hey, I'm worried about this. Is there anything you can recommend, right? Is there anything you can help me with? And we can kind of, dialogue and see if there's anything we can come up with. So don't hesitate to reach out, whether it's me or just ESM in general. Silvio, I recognize both of your names. Silvio, obviously you and I talked last week. Who are you guys working with, just out of curiosity? That would be helpful for me to know. Currently, like, who are you guys talking to from ESM? Silvio, go first.
Currently, with Kira,
Kira?
I've been working with her a little bit here and there,
Okay.
but that's about it just for me.
Okay. Are you working with Kira for comp sci?
For comp sci, physics, and
Okay.
calculus.
Cool. Jackson, who are you working with currently?
I used to work with Eric Harder for
Okay.
just like college.
College counseling. Sure. Yeah.
Mhm.
Okay. Anyone else that you're working with right now?
Not at ESM.
Not at ESM. Okay, cool. Perfect. Okay. Well, I think unless you guys have other questions, I covered basically everything I wanted to. Again, this is mostly motivation to kind of light a fire under you, so to speak, and kind of, figure out where you stand and what you should be doing moving forward. So unless you guys have any other questions, I think we'll actually wrap up here. Is there anything else that you guys would like to discuss or ask before we go?
I think I'm good. All right,
You're
Yeah, I
thank
think I'm good
you.
as well.
Cool,
Thank
perfect.
you for
Of course.
your time.
Absolutely. Like I said, if you guys need anything, you can reach out and find me. Otherwise, I will probably see you guys around at some other point. I think Silvio actually, yeah, we'll talk in a couple weeks. So, but yeah, it's good chatting with you guys. Good luck with the exams and take care.
Perfect. Thank you.
You're welcome.
Thank you.
Bye.
Bye.